Okay. So did you get x equal to what for A2 and then x equal to what for A3? Can you answer me this one? What you have to put for x? So x value we have taken a plus h, and then what are the values? So this is the equal distance one, so you don't need to worry. So you can put a is equal, yes, good. It's equal to 2h, isn't it? So what about the a2? Similarly, this one a plus 3h. And at last we can put a plus nh. Sorry. So can you make it fast? A2 is equal to, using your, forward Newton's forward difference formula as well. Take 1 or 2 steps. We already found a naught is equal to f of a. So you can substitute this one also. A1 is equal to delta fa divided by h. So why silent? Can you find the a2? A2 will be, so if you put x equal to a2h, okay, so the balance will be, so give me a second. So you can say f of a plus 2a, which is equal to a naught will becomes again a1 x minus a no. For the x minus a, if I put ax plus 2h minus a, sorry, minus a, sorry, a cancel out, we have 2h. Okay. Similarly, this one a2, a2 time x minus a again, so 2h, again x minus, okay, a plus 2h is there, minus a minus h, no? So a cancel out, again one more h there, isn't it? Am I correct? Yes, good. So, yeah, I know a naught fa. This one will be delta fa divided by h times 2h. So just substitute whatever you find. This will be 2h square. So h cancel out. So I only need a2. Okay, I can take all the other terms this side. I mean, f of a plus 2h there minus f of a minus delta fa times 2, okay, divided by 2h squared. Okay. So what about this one? What do you think? Can you use your, forward difference knowledge? A2 is equal to, okay, your answer should come like this, delta squared fa divided by 2 squared into h squared. Okay, this is also already there. So 2 is equal to 2 factorial now. 2 times 1 is equal to 2 factorial. That is okay. So you have to make this one into this format. So what is that one? For example, how I possibly can make this format? So gradient squared fa is equal to gradient f a plus h minus gradient f of A. Okay. And then this will be f of A plus 2h minus f of A plus h minus f of A minus f of A minus h. Can you get this one from this? A plus 2h there. Okay. F of A there. Okay. So this one 2 times FA. So 2 times. Okay, I will check again. Did you understand? Delta FA plus H. Okay. So 123. What is delta FA plus H minus delta FA? So delta squared, no? So you got that. Okay, let me check. So we have A2 is equal to f of A plus 2H minus FA minus 2 times, what do you get? A1, no? A1 means delta FA divided by 2H H square. Okay, add and subtract delta FA. Okay. So from where? Okay, for the 2H, the sense f of A plus, what is delta f of A plus H, which is equal to f of A plus 2H minus f of A plus H, no? So correct. So I mean delta. Okay. So careful on the notation. Okay. So what I did is I take one more than this. So A plus H, then I add one more H. Okay. So is that correct? And then, so I can put for this one, I can put this. Okay. So A2 is equal to this one delta f of A plus H plus f A plus H. Okay. Minus f of A minus 2 delta FA. Okay. Delta FA. Let's keep that one. Okay. Divided by 2H, H is, sorry, 2H square only, no? So this is equal to, so if again one more delta coming now, A plus H, this one, these two are what? Delta F of A plus A, sorry, 2 delta FA. Yes, I got it, no? 2H square. So this is equal to, so minus 2 plus 1. So delta F of A plus H minus delta FA. Okay, divided by 2H squared. Okay, this is again delta squared FA divided by 2 you can write the 2 factorial and H squared. Okay, we are making one, I mean, general idea now. So that's why I take as a 2 factorial. Okay. So is that correct? The way I have written. So add and subtract delta FA, is this okay? I have found another way. Okay. So can you tell me the way I have written correct or not? Yes. Okay. So it may takes little, time, but you will get anyhow. Only thing is, for the Newton-Gregory, okay, you have to use the Newton-Gregory forward interpolation. You have to use the forward Newton forward knowledge. Okay. Okay. I hope you got the idea, but I will give this one as your homework. Okay. A3. you have to find delta cube fa same way. Okay, you will get 6, then you can put 3 factorial. Okay, h cube. So likewise, so from this we can find the general idea of an is this equal to, see, 3 3 3 3, everything are 3 now. So an, you can say delta n f of a n factorial and hn. Okay, so this is why we are finding some a1 a2 a3 to find our general idea. Okay, so please take your steps to find out whether it is correct. Okay, keep a space for in your note and we can continue. Okay, so next one, so not we have found in the equation a naught a1 a2 up to an we have found. Okay, so only thing is you have to substitute in our equation number 1. Okay, so let's do it. So if you substitute in the equation says f of x is equal to, for the a naught I can substitute f of a, and then for the a1 I can substitute, let's write the thing, this one first and this one, delta fa divided by h, isn't it? So it is like a 1 factorial there. Okay, so you can write like h of 1 plus x minus a and time x minus a minus h of delta squared of f of a divided by 2 factorial and h square. Okay, so you can write the third one, which continues up to a n term, which is x minus a minus h up to x minus a minus n minus 1 times h delta n fa divided by n factorial time h to the power n. Okay, we just substitute our a values. Okay, so let's take this one, our equation number 2. Okay, still we are not finished because we are finding some hardship to write these values. Okay, we're gonna substitute in some simpler way. Okay, so then again they say put x equal to a plus, let's say, pH. Okay, hp or pH. Okay, so if you put pH, okay, anything, because we are gonna find a plus nh, no, so I'm gonna substitute one value pH. Okay, so what will be the p from this? What is the p? Can you answer me? Yes, good. So what about others? Yes, good. So it means you take this side, so x minus a divided by h, no? That's all. Okay, so then we are gonna substitute wherever x minus a over h, p value. Okay, so if you substitute for x value, you have to put this one. Okay, so f of a plus ph. Okay, what about fa? Fa itself. Okay, for the x minus a, okay, divided by h, you can put p. So p times, we are making this equation more simpler. Okay, that's what we are doing. Again, you can check this value. Okay, yeah, for the x minus a time, there are h squared there for this one and this one. Okay, you check whether it is correct. P into p1 divided by 2 factorial. Okay, check whether it is correct, and then delta squared fa. Okay, and the next term will be check whether it is correct. P1 minus P minus 2 divided by 3 factorial delta cube fa. Okay, likewise our nth term will be P p minus 1, p minus 2, up to, see, for the third one, I need to go up to 2. So here I need to go up to n minus 1, okay? Divided by n factorial and delta n of f of a, okay? So this is our third equation. See whether it is correct. So what is happening? For example, for the x minus a, I can put, if you think pH, okay, pH. Okay, I'll change the color. For example, in this term, see here, for the x minus a, I can put pH, okay? And again, x minus a minus h. If I put x minus a minus h, it will be pH minus h, no? So this will be, I can take h, p minus 1, okay, common. So it will be h time p minus 1, okay? Divided by h squared, no? So h squared. So p into p minus 1 balance, okay? Similarly, you can find whether it is correct. This one, okay? I hope you understood. If you have any doubt also, you can ask. Okay, let's continue our things. We have come to our last. Okay, this is what the this is what the formula. Anyway, for the knowledge of, we use the factorial polynomial now. So like, for example, kn is equal to what in the factorial polynomial? Can you answer me? Oh, for example, k2. What is k2? Yes, good. K into k minus 1, isn't it? You have to go until 1 less than. Okay, this one k into k minus 1 times up to k minus n minus 1. Okay, so we're going to use that also here, okay, to make it simplify. So f of a plus ph, which is equal to, okay, f of a plus, see here what's happening is, what we have come to the, this is how you can memorize this one. A plus pH. So first you have to write this term only, f of a. Okay, then you use the p one time. Okay, and then and delta f of a. Okay, next term will be p into p minus 1 delta squared f of a. So here like 1 factorial. Okay, we don't put anyway. This is 2 factorial. So next term up to nth one will be p minus 1, p minus 2 up to p minus n minus 1 delta n f of a divided by n factorial. Okay, so I have some idea like this now. So I can use that one, f of a plus, for the p I can put p1. Okay, p1 itself what? K1 will be k itself, no? Yes. So again delta fa, again for this one I can use this one, p2. Okay, p2 of delta squared fa divided by 2 factorial. Again, third one I can use p3 delta cube fa divided by 3 factorial up to, I can use p to the power pn n factorial delta f fa. Okay, just for the memorization. Okay, just to make our things easier. This is our equation number 4. So this is what we called as a, so see here how this developed from this fa plus ph will be f of a, again p to the power 1 delta FA, again P 2 polynomial, again 2 factorial delta square. Again P3, 3 factorial delta 3. Pn n factorial delta n. Okay, so very easy to memorize hereafter. Okay, so if you understand, it will be very easy. So this is what we called as a Newton-Grigori formula for. So since we are using the forward interpolation, this is a forward interpolation. Okay, so I have sent you the module with some, most of the steps are there. So only thing is you have to, fill up the rest of the thing. Okay, so we can see some example how we can use this formula. Okay. Okay, let me use the homework quiz. What's the number? Fifth, I guess. Okay. So let me see. I'll do the question. Okay. Given that, so they have given some sign values. Okay. What is sine 45, 50, 55, 60? Still we are in the equal increment. Okay. So they are asking you to find the 52. Okay. They have given you 45, 50, 55, sorry, 60. So you have to know, okay, 52 is somewhere here. So it's an interpolation, isn't it? So here we're going to use our forward Newton-Grigori forward interpolations. Okay. So same idea things, but only a small modification of what we have done earlier. Okay. So let me do this one. So this is our x values. Okay. And then yeah. So y value, delta y, delta squared y. Still we're going to use our Newton's forward table. Okay, so the y value has given us 0.7071, 0.7660, 0.8192, 0.8660. Okay, so first of all, you make up this table. So let me put the index also, so it will be easy for the calculation. So n is equal to 0, 1, 2, 3. Okay, so what about delta y1? Delta y, is that y1? Y not, no? Y1, delta y2. So in the backboard only, you have to put one more here, nebula y1. But here for the delta, you can put the same index, okay? So this will be delta squared y0. This will be delta squared y1, okay? This will be delta cube y0, okay? Okay. Can you answer me these things? So also you can notice from the things. So we need to find the P also, no? Let's find out the P first of all, okay? So you can make this table also. They have given A is equal to 45, okay? 45 degree, okay? So first one, X naught will be 45. Then H is, you can see 50 minus 45, 5. So all are equal, no? So H is equal to 5. So we know A plus PH is equal to, they ask you to find 52. Okay. So from this only we need to find our, P. Okay. So if you phi is equal to what? 552 minus A divided by H, no? So you can find the P also. Okay. So then only we can substitute in our, equations. Okay, can you answer me this one as well as P? So then that's all our work. Then we can substitute in our equations. So can you get the answers? Yes, the answers. Okay, what about the P? So 52 minus 45 divided by 5, no? What is a P? Okay, 1.4. Is that? Okay. So what about delta Y node Y1? Can you find this one? Okay, 0.0589. Next one. 0.1592. Is that correct? 532, no? 0532. Okay. Delta Y2. Okay. 0.0468. Okay. So now find out delta squared Y0 and Y1. Mm. So correct? 0003. What is this one? 0.0532 minus 0.0589. That negative, no? Negative 0.00. Sorry, what's the answer? 0.0057, sir. Okay. What about this one? Okay. Minus 0.0064. Good. Okay. Final. Minus 0.0007. Okay, thank you. So that's all the things. Okay. Okay. Now we're gonna substitute in our equations. So in this substitution, see here one more thing. Okay, I'll show you in our equation. Yeah. See this one. All these are f of a, no? What is our actually f of a is our x naught terms, isn't it? So this is all these terms are regarding the first initial value, I mean x naught value. Okay. So it means, so you have to take down this, I mean, regarding this value. Okay, this. So you can take like this. This one, this one, this one, this one. Okay. I mean, this one delta y naught, delta squared y naught, delta cube y naught. Okay, everything are regarding this initial value. Okay, so you can they are marking like this, for example. So in the table, okay, so you can see in some books also they have used some. So in this way we use the forward one. So in the backward you can see it goes this way. Okay, like this. Okay, so we can see that later. So let's use these values are we're gonna use it. Okay, so let's use it in our equation again. So what is our equation actually? F of a plus pH, which is equal to f of a. Okay, in this time of period you can memorize it. Okay, delta f of a plus sorry, you can put f1 p1, this is p2 delta squared f of a divided by 2 factorial, p3 delta cube f of a 3 factorial. So how many we have? We got we have delta fa there, delta squared there, delta cube there. That's all we have now. So we don't need to put everything. So this is like our y of f of a is what? Y of 45. Okay. So you can put our initial value as well. So this is like a plus ph now. So our f, y of 52. Okay. So this is what we are looking for. Okay. Which is equal to p. What is our p? So you can also, if you are, you can make this one again like this one, delta fa. So what is our delta fa? 0, yeah, times 0 point. Okay, give me the answers. What is delta fa? 0 point. It means y, delta y naught. What is delta y naught? Make it faster. Okay, 0.589. Okay, so this one we know p into p minus 1. Again, you can transform this one. Okay, this is for memorization. This is we need to use for the calculation. Okay, delta squared, y naught, delta squared y naught. What is that? Minus no 0 point. Yeah, only one answering. That's the other. Plus p into p minus 1, p minus 2 divided by 3 factorial. I can put 2. Here I can put 6 time delta cube y naught. Okay, minus 0.0007. Okay. Okay, which is equal to, that's all. You have to substitute what is p, what is. So this is, so this will be, yeah, only thing is you have to substitute the value. Okay. So p will be, y45 will be 0.7071, isn't it? Plus p will be 0.14. So put it in a bracket for the easy calculation, 0.0589. Okay, plus p, okay, 0.14. Again, p minus 1, it will be 0. Okay, if you don't need to make some mistakes, so you can write that 0.14 minus 1. Okay, divided by 2 times minus 0.0057. Okay, again third one, 0.14, 0.14 minus 1, 0.14 minus 2 divided by 6 times minus 0.0007. That's all. So only thing is you have to calculate it. Okay. So see whether you get the answer 0.7880. Okay. So that's what this used for. Okay. So in the, forward trigger, you have to use these values only. Okay, every time. Because it's the equation itself have the initial point. Okay, so you have to use in the table, you can mark it also. Okay, So this is what I'm gonna find. So this is easy for you to pick the things. So is that okay? So the answer correct? So yeah, I know it takes some time, but check whether you're getting the answer. I think our time is gonna finish. So check whether I also put some 1 or 2, 3 questions under this section. Okay. So similar way. Okay. And in our next lecture, we can discuss Newton-Gregory backward difference interpolation. But in the meantime, I want you to work on it. Okay. All the procedure, all the things are same as what I have done now for the forward. Okay. Backward thing is only you have to use a nebula. Okay. Nebula terms and the same ideas. And there's nothing new here. Okay. So I want you to work out on it, and we can lightly we can discuss next lecture, and we can continue. Okay. So is there any doubts or anything you want to ask? I hope you're okay. From your answers, I feel you're okay. Only thing is you have to calculate, okay? But this numerical thing takes time. But the examination point, anyhow, you have to be quick. You have to practice all the calculator things early as possible. When you're studying, you make. I have already told you, buy one calculator, good calculator for yourself. Okay, keep practice on it and bring that same calculator for the exam as well. Okay, so it will be easy for you to work with. So shall we end the lecture? We have only 1 or 2 minutes. So did you get this answer? Can you answer me? Is this coming? Or maybe some wrongs. I don't know, but hopefully it's correct. Okay. Yes. I think one of the person answer yes. So hopefully everyone can get the same answer. Okay. So you can also check me like, yeah, okay. 880032. Yeah, we have taken for 4 digits, isn't it? So most of the time we take, but it's okay. If they don't ask, you can put full answer. Okay. Then after that, you just approximate to the 4 decimal. Okay. And then, yeah. So that's all about this for the EQ distance. Okay. So we can also discuss what if unequal distance comes. So that is our next lecture. Okay. So yeah, I'll finish this lecture now. Thank you.